Hello, everyone. Thanks for coming here. We're going to talk about container security today. My name is Yash. Full name is on there. If you want to take a try at butchering my name, you're welcome. Okay, who am I? So I've been in InfoSec about 6 or 7 years now. Currently, I do product security at Twilio. Some other fun facts below that. But if you want to get in touch, that's my Twitter handle and my LinkedIn. Agenda for today, little introductions, then let's talk about containers versus VMs quickly. Then I'll convince you why you need container security. Then we'll look at a very high-level, very generic container deployment pipeline. Then we talk about different ways you can build security into that particular pipeline, and then different ways to scale and potential issues, and some resources that I really found helpful when I was learning containers and container security. Quick disclaimer. When I say containers, I mean Docker containers. I know there are other types of containers, but we're going to talk about Docker. I'm not going to cover orchestration, so if you're here for Kubernetes, Docker Swarm, or other orchestration security, I'm really sorry. I talk about a lot of tools in the presentation, but I do not endorse any of them. A lot of configuration options that we'll talk about may break stuff, so use these at your caution. Try them out. They may work in your case, may not work. Just be careful. And there's always more to containers and its security, right? So this is not it. Okay. VMs versus Docker. Probably everyone in this room knows the difference between a VM and a Docker container. In VMs, you have your base machine, and then you have a hypervisor which runs a whole another operating system on top of it, which then runs your application. But for containers, on top of your host operating system, you have a Docker daemon or any container daemon running, and that runs your containers as processes. Why do we need container security? That's almost like asking why do we need security. I'm not really going to do that because this is a room full of InfoSec people, right? Let's talk about VM versus container security, though. In a generic sense, if an attacker compromises a VM, the attack surface is most likely within the VM itself. Sure, you can break out of the VM, but breaking out of a VM is way harder than breaking out of a container. So again, sorry about my very minimal graphic skills, but this here I've tried to depict a generic container deployment pipeline. You have your code repository where your developers or your ops folks would write Docker files. They would then get picked up by your build systems, and that build system will pull in a base or a parent image while building that image, and then that gets stored into your Docker registry. Then you have your orchestration layer, which pulls in a bunch of configuration files or configs that you put in, and then also pulls in the image and creates a container and deploys it into your different environments that you have. How can you secure this? These are some of the ways that you can add security. First off, you could start off with Dockerfile Linting. You could always do vulnerability scanning. You could do it in different places. Then there's base image security, registry security, and coming to the right side of the screen, orchestration security, obviously, securing the host on which your containers run, Docker daemon security, runtime security. There is a bit of overlap between runtime security and Docker daemon security, but we'll get into that shortly. And obviously, there's always logging and alerting. Okay, base images. What are base images? I just wanted to quickly clarify between an image, base image, and a parent image. So when you write a Docker file, you reference another image to be the base of what you're building. So for example, on the other side of the screen, you have from Ubuntu. So Ubuntu is going to be your parent image, because that's what your image is going to be based on. But when you're writing a Docker file, you start from scratch. So that particular image, when built, is not going to depend on anything else. That's called a base image. Talking about base image security, we can generalize this to apply to any image that you let your developers reference as their base or parent image. So this would be any image that can come in a from statement in a Docker file being written by your developers. Why do you need base image security? That base image, if it contains vulnerabilities, that is going to propagate to all of the containers that are built on top of the base image. So that's going to be a lot of containers. So you need to secure your base images. What can you do to secure your base images? Whitelist trusted base images. Pulling base images off the internet is not a good thing. There have been recent studies that show a lot of images available publicly have known vulnerabilities in them. So the first thing you could do is whitelist trusted base images. These could be ones that you build from scratch or get from a trusted source. And do not allow any other base images to be deployed or referenced in your environments. Keep them small. You don't need a big base image. Like you don't need to install each and every package your developers may or may not need, because if you do that, then there's a bigger surface area. That means a bigger attack surface, which you have to keep patching. So that kind of propagates down. Regularly patch base images. You probably have a patching mechanism or a patching process in place, so put your base images through that. If you don't have a patching process, then you have bigger problems to solve. Quick note on patching base images. So every time you release a new version of base image, be it a security patch or something else, there's always the problem of getting that new version into all the Docker files that everyone's writing. So Salesforce has a tool that they open sourced, which is called Dockerfile Image Update. You could tell it, this is the base image, this is the new version that I want people to use, and it'll go create PRs in your code repository to make people use the latest version. Small inventory of base images. Again, keep it simple, have minimal number of base images that you need, keep them secure. Dockerfile linting. What is a Dockerfile? Dockerfile is a text document that contains all the commands that a user can call on the command line when assembling an image. Quick difference between image and container. So when you build a Dockerfile, you get an image. When this image is run, then you call that a container. What is linting? Linting is the process of finding potential errors by analyzing code. Why do you need Dockerfile linting? So with the whole shift left kind of approach people are adopting, Dockerfile linting is probably the earliest phase where you can catch potential errors and bad practices that you do not want your developers to be doing. What kind of things can you look for when you're performing Dockerfile linting? Using the root user within the container. Most applications don't really need to run as root. They can run as a non-privileged user within the container. So that's something you can figure out pretty early on in the process. Secrets in Dockerfile. I'm not going to spend too much time. We all know why secrets in code are bad. Whitelisting or blacklisting software packages. You probably have a package management strategy, a whitelist of sources from where you pull packages and things like that. So you could do the same with your containers. Using apt-get update in a single line. So this one's a little more interesting than the others. the way images are built is when you give Docker a Docker file, it runs each command or each line in the file and creates a layer, and it caches the layer. If the same set of commands is in another Docker file, it reuses the cache until there is a change in the command. So if the first 3 commands are the same, it's going to use a cache, and then when the 4th one changes, it's going to build that again. So if you have an update statement in a Docker file and that overlaps with another one, so there is a good chance that when Docker is building the second image, it's going to use the cache and you're not going to get the latest update. The way you could sort of solve this problem is use the update instruction along with install, or you could do use a no cache flag during Docker build. Copy instruction just copies files from the local host into the container, but add can potentially do other things like retrieving files from remote URLs, which has the potential of unpacking vulnerabilities and things like that. Mounting sensitive host file systems to the container. So, as an example, if you mount the Docker socket into a container, then that particular container will get access to all the other containers that are running on the same host. So you need to be careful as to what file systems you're mounting from the host onto the container. There are a few Dockerfile linting tools out there. Most of them are based on Dockerfile best practices, not necessarily geared towards security, but a lot of security checks are already covered, and you could pick one of them and sort of build on top of it to add more security checks that you want. Okay, container registry security. What is a container registry? Registry is a storage and distribution system for your images. So you build your Docker images on your local host, and then you push them to a registry, and then you pull them when you need them. So it's essentially storing it for you. There are a lot of different registries out there: AWS, JFrog, DockerS, Docker Hub, and more than the logos that are shown on the slide. Why do you need to secure your registry? It's not going to be a good day if somebody gets access, read or write access to your registry, which has all your images, which probably are private in some form or fashion. What can you do to secure your registry? That's the next question. Use a private registry. In Docker terms or in container terms, a registry is private if pulling or pushing images to the registry needs authentication. For example, you can pull an image from the public Docker Hub without authentication. That's a public registry. But Docker Hub also has a private registry which you need credentials to pull and push from. Role-based access control on your registry. Not everyone in your organization needs access to read or write to your registry. So use a privilege of least principle of least privilege. Use a V2 Docker registry. So Docker registry has V1 and V2 versions. V1's been deprecated. It is still supported by some registries for legacy purposes, but make sure you use V2. Use a secure registry. Insecure registries are ones that don't have TLS enabled or have a invalid certificate. Do I need to convince anyone why we need SSL or a valid certificate here? I'll take that as a no. Docker Content Trust provides the ability to sign images and verify the signature between pushes and pulls. So if it's a remote registry that you're working with, you can verify signature of who pushed the image when you pull it. Vulnerability scanning in containers. There are a lot of scanners which, I'll take a step back. How does scanning work in the container world? As we talked about different layers of images, most scanners, they pick these layers apart, see what each layer has, and for example, look at the software versions that a layer is installing, and then look at publicly available vulnerability databases to see if that version has any vulnerabilities in them. There are a lot of open source and enterprise tools available. A lot of the enterprise tools do a lot more than just scanning, so check them out. If you're in the process of selecting a scanner for your containers, there are a few things that you need to keep in mind. Look at the vulnerability sources or databases it's pulling from, and make sure that they include the ones that you use. If your containers are based on Alpine and the scanner doesn't have the Alpine vulnerability database in it, then there's no point of using the scanner. It's always going to come out clean. Deployment model. There are different deployment models. There are on-prem, cloud. There are on-prem ones which pull vulnerability sources from the cloud. There are also a few which can pull from a local vulnerability source. So make sure to check the ones that suit your needs the most. Access needed. So the difference here is some scanners, they just need access to the registry, and then you give them a repo and a tag to scan. They scan the image and then give you the vulnerabilities in there. So all they need is read-only access to your registry. There are other tools which need a lot more access, but they also provide bigger or other features like insight into your running containers. Machine learning is a term that's being thrown out by these companies as well. I haven't looked very deeply into them, but there are a lot of different things which companies are doing or vendors are doing. What's your budget? I guess you probably would start with that and then go down the road of doing an actual POC. Few things to watch out for. Load on your registry is definitely going to increase, because if you are putting this in your deployment pipeline, then with every build, your scanner is going to make a pull request from the registry. So that's a significant number of requests that are going to increase. Make sure you have a plan of keeping the vuln feeds updated on a regular basis. Also, then there's the case of vulnerabilities with no patches available. What do you do with those? One good strategy would be to see if you really need that package and remove the package from the image itself. So container orchestration, there are different ways you could do this: Kubernetes, Docker Swarm, Mesos. Not going to cover too much of this, but check out the CIS benchmarks, and if you're using Kubernetes, I would highly recommend checking out KubeHunter. Host security is your standard host security. Harden the host, keep it as small as possible with minimal softwares installed. Update everything, have a patching process, update Docker. That's probably the one that stands out for this talk. Talking about Docker daemon security, let's start with what is the Docker daemon. So the Docker deployment model has different layers. The daemon runs on the host, and on the host or the server, and it exposes a REST API with which the client or the CLI is going to talk to. So when you issue a command, say Docker image build or Docker container run, the CLI is going to talk to the API, which is exposed by the Docker daemon to do things for you. Docker daemon security. Make sure you review access control on the daemon as to which users on the server actually have access to the daemon, because if unauthorized access to the daemon is possible, then that can lead to compromise of all your containers. Audit your daemon. Make sure your Docker daemon is doing what it's supposed to do. Daemon config. This is something we're going to dig a little more into. So Docker daemon config is a JSON file that is on different locations on Linux and Windows. Mac has a UI as well if you want to play around with it. There are different settings. Most of them are geared towards performance and other things like that, but there are a significant number of security options in the Docker daemon as well. One thing you could do, so we'll talk about a lot of these options that are security specific. One is restricting inter-container communication. So by default, all network communication between containers on the same host on the default bridge network is allowed. Setting this flag in the daemon will restrict inter-container communication. Another thing to point out here is Docker has the ability of creating different networks, and you can assign these networks to different containers, thereby achieving a little network segmentation. Setting appropriate log levels. By default, Docker daemon is set to the log level of info, but depending on what you need, you can change that log level on the daemon. Do not enable insecure registries. So by default, Docker assumes all registries except the local, except the one on localhost are secure. But you can set a list of insecure registries that the daemon should accept or should communicate with in the daemon config. Do not do that. Enable auth for Docker daemon. So by default, the daemon binds itself to a non-network Unix port, but you can configure it to listen on the network on a TCP port. If you are doing so, make sure you enable this option in the config, which enables TLS authentication for the daemon. Otherwise, it's going to be an authenticated daemon listening on the network, which anyone can manipulate. You can set ulimits. Ulimits are a way to limit and control usage of system resources. User namespaces, a Linux feature that can be used to separate user IDs and group IDs between hosts and containers. C groups, again, limit the network usage of different processes running. Disable legacy registries. Starting with Docker 17.12, I think, operations against V1 registries or legacy registries are not supported. The Docker daemon has an option to explicitly disable legacy registries. But if you use that, the daemon is going to break. So just a heads up, some older guidelines may ask you to do that, but make sure that your daemon does not break. Enabling live restore. Live restore makes sure that containers can run even when the daemon goes down. So a lot of the daemon updates require a restart. So if you have live restore enabled, you can update the daemon without stopping your containers. Experimental features are called experimental for a reason. Don't enable them in your production. You can, so there is a flag in the daemon that you can use to disable experimental features. You can restrict containers from acquiring new privileges using the SUID or SGID bit using so there is a no new privilege option in the daemon that can do this for you. Enabling seccom profiles. Seccom profiles enable you to restrict containers from accessing the system calls. Docker, by default, has a seccom profile which disables around 44 to 45 system calls, but in total there are like 300 plus of them. So based on your usage and use case, you can disable more of them and build your own profiles. This is a sample daemon config. Just sets debug to true, live restore to true, and a few other things. Docker uses a lot of volumes and files that are stored on the host to function properly. make sure that appropriate user permissions are set on them. The CIS benchmark has more details on the exact permissions that each of the files and folders that Docker owns and uses should be set. So there is a tool, Docker Bench Security, that you can use to sort of audit your whole Docker daemon config plus other configurations. It is based on the CIS benchmark and checks against a lot of common best practices. But just a heads up, it runs with a lot of privileges. You have to share the host file system, PID, network namespace, and a bunch of other things for it to actually give you the results. This is a sample output. As you can see, it's color-coded, which is kind of nice, and it has different sections for host configuration. Then there's the Docker daemon configuration. There are other sections for Docker Swarm and a bunch of other things as well. Docker Runtime Security. So the options that you enable in your Docker daemon apply to all the containers that the daemon runs, but there are individual options that you can tweak when the Docker run command is used. I want to talk about a few security options in here. You can enable AppArmor profiles. You can create your own AppArmor profiles, or you can use Docker's default profile as well. Bane is a good tool that helps you generate custom AppArmor profiles for containers. If you don't want to use AppArmor, then you could use SE Linux. Docker does not provide any default profiles for this. Privileged containers are a type of containers that you can run on Docker, but they let that container do pretty much everything that the host machine can do. Do not run privileged containers. Run containers as read-only. There is a mode in Docker called read-only. Can anyone guess what it does? The problem with running containers as read-only is not a lot of images supported, because a lot of them will still expect to be able to write to the file system to perform different actions that they need to do. But if you are able to run your images as read-only containers, it will help enhance security. Logging in containers. Docker support for different log drivers has increased over time. There are a lot of drivers that it supports by default. You could set the specific driver that your organization would benefit from in the daemon config. If the driver you need is not supported by default, it also has a plugin capability using which you can extend the default drivers that it comes with. The default driver is a JSON file that it writes. These are just some of the different drivers that it supports by default. One small differentiator between Docker Enterprise and Docker Community, which relates to logging, is there is a Docker logs command in the CLI using which you can get logs from a container. But that command is only available for a few driver types if you're using the Community Edition, but if you're on the Enterprise Edition, it'll work for all different driver types. Real-time alerting in containers. Essentially, your app should be the only process running within the container. A shell should not be spawned randomly on your container, right? So wouldn't it be nice if you can get an alert if a shell is spawned in a container running in your production, or say files are copied from the container to somewhere else? There are a few tools that do that too. Cystic Falco is an open source solution. It's a rule-based engine. You can write different rules. If X happens, then do Y kind of thing, and it has visibility into all of your running containers and can alert you. There are enterprise solutions like Twistlog, Aquasec, and Sysdig as well. Ways to scale. Containers are supposed to be fast, right? So security around containers has to be fast as well. You can embed them into your pipeline depending on your organization's appetite for security blocking builds. You can either block builds during your whole CI/CD pipeline if vulnerabilities with high severity are found, or if the appetite is low, then you can go with creating tickets after. One thing I've noticed is developers want to do the right thing, so giving them as early feedback as possible helps getting things done, and automate as much as possible. Few issues that you may face. As I mentioned, load on your registry by the scanner is definitely one that you want to check with your ops folks to scale the registry as needed. If you're blocking builds, make sure there is a emergency release plan in place. If there's an incident, your systems are down and they're trying to repair it, you don't want a security scan to be sort of blocking everything else, right? Scans, if being done during build process, will definitely increase the build time. And again, make sure you have a plan in place for working with vulnerabilities which have no patches available. These are some of the resources that I found helpful, good reading material. One of these that I want to call out is, where did that go? The Veggiemonk Awesome Docker repo. It has a list of a lot of tools that can be used. Thank you for listening. Any questions? Yep.
Have you had any experience in working incident response cases in containers, and how does that process change when you're dealing with Docker containers versus virtualized hosts or conventional hosted space?
So, are you asking about like how would you do real-time monitoring and alerting, or like forensics?
Well, the whole incident response process is what I'm more interested in. I found that customers that I'm talking to are seeing compromised containers, and they're just destroying and then rebuilding containers. And so we're losing any evidence that we have for analysis after the fact. And so far, we're not really seeing a lot of best practices or recommendations on how to respond to compromised containers so that we are informed about what happened and how to remediate and how to fix those.
So some of the tools like Sysdig, Falco, and some of the enterprise ones, the way they work is they hook into the Docker socket. So they listen to everything that goes on. So even if a container spawned and then killed, they would still see what happened because they have insight into the socket.
So are they like gathering memory in real time and things like that?
I'm not sure if they do memory analysis. I'm sure some of the tools can. But if you're reading the socket, it's like what container spawned, what is it doing, and then when is it going down, and things like that are available in the socket communication. Yep.
Do you have an opinion on a manageable way to create rules for inter-container communications? So we built pods, and containers can broadly talk to one another. It makes me a little uncomfortable. But how can developers properly express what they expect the containers to do with one another?
I don't have super deep experience, but I'm assuming you use Kubernetes since you mentioned pods. So they have labels and different methods that you can use to say these are super sensitive or these are not, and you can have rules saying these should not talk to each other and things like that. Or you could have a label that says these all belong to a service and they should talk to each other. Anyone else? Yep.
I know you mentioned making secrets safe. Do you have a couple of examples of tools you use? I've heard like HashiCorp and Orchestration Security. Do you have anything that you have experience with that?
So Twilio has its own way of doing secrets. So I have an in-house build solution, but I know HashiCorp Vault and other solutions do work with containers.